Okay, so grab a whiteboard and we're going to introduce two-column proofs. And you're going to be working for the next about seven days or blocks, and every day you're going to go to a station dealing with proofs, okay? How to write them, the basics of them, and everything. So a proof is kind of like a puzzle, and so if you really like puzzles, you may actually like to do a proof. So in order to do a proof, you start with the given information, and then you have what you have to prove, and that's kind of like your goal. So you have what you start with, and you have your goal here. And then to do all of this, you need to logically prove that you can get from what you're given to your end result, and you're going to need to use statements and justifications and kind of link them all together. And so this unit is really going to focus on basic setup of two-column proofs, and you're going to be doing these two-column proofs in every single unit. So it's really important that we get the structure and how to set one up, okay? Justifications can be properties, postulates, and theorems, and those have already been proven or accepted as truths. So last night you looked at the segment addition postulate. And that is a postulate that you could use in a proof when doing this as a justification. So here are some properties that you already know, so that's a good thing. We have the addition property of equality and subtraction property of equality, multiplication property of equality, and the division property of equality, basically stating when you do the same operation with the same real number to both sides of an equation, your equation is going to remain true, or false if it started out as false. You also have, you heard of this last year in Algebra 1, the reflexive property of equality. Basically, a number is equal to itself. If you have x, the x is equal to itself x. Well, we also have reflexive property of congruence. It's a little bit different. But basically, it says that a figure is congruent to itself. So angle A is congruent to itself, angle A. We also have the symmetric property of equality. Same thing here. There's also a symmetric property of congruence. And the symmetric property is the sides of an equation can be switched. Well, in congruence, the sides of a congruency statement can be switched. So if angle A is congruent to angle B, then angle B is congruent to angle A. You can just switch them around. That's a symmetric property, both of equality and congruence. And then we have transitive property. Transitive property, if two numbers are equal to the same number, then they are equal to each other. So if A equals B and B equals C, then we can say that A equals C. Well, there's also a transitive property of congruence. If you have two figures that are congruent to the same figure, then they are also congruent to each other. So if angle A is congruent to angle B, and we know that angle B is congruent to angle C, then we also know that angle A is congruent to angle C. So we can see that our properties of equality are really the same. Their properties of congruence are the same thing here. Okay, so here's where I want you to grab your whiteboard. See if you can go ahead and pause the video, look at the screen. Can you identify which property was used to get from column 1, so this column, to column 2? And then down here, you're trying to write a new congruency statement using the transitive property for 5 and for 6 here. So go ahead and pause the video, and then when you're ready to hit play, go ahead and hit play, and we'll get to the next slide, which has the answers. So number 1, that is the subtraction property of equality. Now, if you notice, you could write this statement here, or you really don't need to write that statement, and you could only write this one here. And that's probably what you will be doing now that we are in geometry, is you're not going to show this minus 9. You would just subtract 9, and then this is your answer, and your justification would be the subtraction property of equality. Line segment JK is congruent to line segment GH, and then they switch them around. That is the symmetric property of congruence. Okay, and here we have angle QRS is congruent to angle UVW, and angle UVW is congruent to angle XYZ. We can conclude or make a logic conclusion here that angle QRS is congruent to angle XYZ, and that is a transitive property of congruence. Number 4. Measure of angle 4 is equal to the measure of angle 9. Notice they put in the M there. That's because these are talking about actual geometric figures, and then when you put a measure, you're talking about a number, and so therefore you can have an equal sign. So we have the measure of angle 4 equals the measure of angle 9, and we see here that they added the measure of angle 1 to both sides of our equation. That is the addition property of equality. Very important that we understand that these figures here, we cannot use an equal sign because they're not talking about a measure here. And so notation is extremely important in geometry. All right, number 5, our new statement would be angle ABC is congruent to angle JKL. And for number 6, we have line segment VW is congruent to line segment XY. Okay, let's talk about the substitution property. The substitution property of equality, if two numbers are equal, then one can replace the other in an equation. Kind of like if you remember substitution when we did linear systems, kind of like that. Substitution property of congruence, same basic concept of equality, except that this is if two figures. So we're not talking about numbers, we're talking about actual geometric figures, so line segments, angles. If two figures are congruent, one can replace the other in a congruency statement. So here we have an example. Example 1 is using the substitution property of equality here. If the measure of angle G is equal to the measure of angle H, then we know that the measure of angle G plus the measure of angle A equals the measure of angle B. So what we can do is we can really rewrite this so they're going to replace the G with the H in this statement here. It seems kind of silly now, but you're going to see that this property is used quite often actually in proofs to be able to make your logical reasoning and get to your end result here. Example 2 is using the substitution property of congruency. So we have if line segment TV is congruent to line segment WX, and we know that line segment WX is congruent to line segment YU, you can rewrite the statement, and basically they're replacing the line segment WX and they're replacing it with the TV down here. So line segment TV is congruent to line segment YU. And again, you're going to see that that is used quite often in your proofs. Okay, so the substitution property and the transitive property can be used for full expressions as well. So if we look at the following, we are given that D equals C, A equals C, D plus P equals N, and A plus C equals N. Depending on your goal, and your focus should always be your goal in a proof, we can write quite a few statements from those equations. Since two different expressions are equal to N, they are equal to each other, so we can say these two are equal to each other. So D plus P equals A plus C. Sometimes it does help to put boxes around those. See if you can write 4 different statements, writing really as many as you can on your whiteboard, and then checking with each other, did you make an equal statement? Couple reminders. Angle measures are numbers and can be equal, but angles are figures and can only be congruent. So your big thing here is this M. If you're using an M in front of an angle symbol, that is talking about a measure, and those need to have an equal sign because that is an actual number that you're trying to represent there. Where if you do not have the M in front of this angle, you're talking about the figure, and so you need to use the congruent symbol instead of the equal symbol. Same thing with the lengths. Segment lengths are numbers and can be equal. You notice that there is no line above here. That is because we are actually talking about its length, its numerical value. But when you put the line on top, that is actually now talking about a segment, a figure. And those can be congruent. And so it's very important that we get those two down and not confusing them. Okay? So what I want you to do is see if you can determine whether the statement is acceptable and explain. So see if you can do that here. So you may need to pause the video when you're ready to check it. You may go ahead and hit play. Okay, so here are the answers. Number 1 is incorrect because there's no M in front of that angle, and so they are talking about the actual figure, and so there needs to be a congruent symbol in between. 2 is correct. There is no line above the VW or VY, and so you're actually talking about their lengths. So those are measurements, and those are equal. 3, same thing as number 2. We're actually talking about the length, so you need an equal sign, not a congruent symbol here. Number 4 is correct because they have an M in front of the angle, so you're talking about the measure of that angle. That is a actual number. You need an equal sign. And then for number 5, that is incorrect because you have the line above the 2 letters, and that indicates that it is a figure, a geometric figure, and there needs to be a congruent symbol, not an equal symbol there. Okay, and so we're going to end with our segment addition postulate. Just to reiterate here, if B lies between A and C on segment AC, then the length of AB plus the length of BC is equal to the length of AC. And that is just a reminder for the segment addition postulate. But at this time, you can go ahead and work together and work through the properties of equality and congruence paper. And the answer keys are available to you when you are done.